All right, good afternoon. I'm Lieutenant Orr from Amphibious Construction Battalion 2. I'm the ELCAS OIC for the 2015 ELCAS build. So ELCAS is a assault follow-on echelon mission to be able to support the Army and other joint forces in providing throughput capability or enhanced throughput capability to certain beach fronts that may not necessarily support multiple beach landing sites. So the ELCAS itself is put together with pontoons that are 40 feet wide, or 40 feet long by 8 feet wide by 4.5 feet tall. So they're cantilevered off of another section. Then they are supported by chute bolt locking pins. And then you'll have external spud wells that actually house piles. And the whole system itself is supported by grippers that are torqued down to about 700 foot-pounds of torque. So the piles are driven by a diesel-powered pile hammer that actually drives the piles down to a 37 blow count over a specific foot, and that actually translates to a 100-ton bearing capacity that supports the whole system. So the ability of the ELCAS to actually sit above the water of a fixed pier system that sits 7 feet above mean high water, it kind of eliminates the wave action or some of the other sea state type anomalies that come along, and actually take take floating causeway, for example. So you have the floating causeway that sits right above the water. You're trying to transport cease in maybe sea state 2 or sea state 3. It gets to the point where it's almost unsafe to actually do that. But then you have ELCAS that sits 7 feet above mean high water and completely eliminates that wave action from even affecting the system. So you're talking about a system that can not only survive at sea state 5, but the only limitation for sea state is the crane's ability to be able to actually pull off containerized cargo off of those pieces of lighterage to be able to put it on MTVRs or tractor trailers.
Hey, I'm SW2 Cook, and I am the pile yard supervisor this year for the Elevated Causeway System. And right now we're standing in front of the pile yard. What we do is there are 3 lengths of pile, 38, 57, and 76 foot lengths of pile. We have oxygen and acetylene rigs, usually 3 or 4 of them, and we have track torches that we set around the pile, wrap it around. We set our motor and we set our flame, and we basically turn it on, and it runs the whole distance, the whole 24-inch diameter of the pile, and cuts it at 30 degrees. 30 degrees on both sides. We push it together, and that's when we start our weld. And depending on how far the elevated causeway, the actual pier and the pier head and roadway are going to go, that's what we weld. With 38 footers, they come straight out of the bin. Now, if they get to a point in the roadway and they need 57 footers, then we will cut a 38 footer in half, and we will weld that, splice it together with a 38 and a 19 and make a 57, and we will just stockpile whatever we need to accommodate for the roadway and pier section. If we need a 76 footer, we will obviously do 2 38 footers, splice them together, set them aside, and whenever the pier head or the pier head soup deems that they need more pile, we load our mini pile bin, and the Calamar will take it to them, and they will pick it and put it in place, grip it down. And basically our job in the pile yard is to cut, bevel the pile, and splice it together.
I'm CE2 John Stewart. I'm the marshalling yard supervisor here at ACB2. This is where we stage our cans that we would take up to the pier head. We usually start with the G cans to make the ramp. From the ramp it goes up to the roadway. And then further down, we will take the S cans and the F cans as they need them. G cans are our general purpose cans that we use for pretty much the entire roadway section and ramp section, along with most of the pier head. When we get to the pier head, that's where the S cans and the F cans come in place. The F cans are used for the fenders. They actually float on the water and go up and down as a tide, and they're used for the impact or for cushioning craft as they come up to the pier. After the pier is constructed and throughput operations are completed, we will start retrograde, all the cans will come back to this position. We'll strip them of their connectors and stage them for the 5-wide.
EO1 Amanda Sidnor, Crane Operations Supervisor at PHIBCB 2. During the pile extracting process, we use a vibratory hammer / extractor manufactured by American Pile Driving Equipment. The vibratory extractor itself has 3 parts: the clamp, the gearbox, and the suppressor housing. The vibratory hammer is operated by the hydraulic power unit, which is run on environmentally friendly, biodegradable hydraulic fluid. There's 150 foot of hose that runs from the HPU to the extractor. During the process, the crane will pick up the extractor and place it over top of the pile. You want about 4,000 to 5,000 PSI on that clamp as it engages. Once the clamp is engaged on the pile, the operator of the extractor will have a remote and will operate it from the ground. And once it's clamped, you can vibe the hammer. The extractor can be operated in 2 different ways. It can be operated straight from the HPU or from the remote that comes out of the HPU. For safety reasons, we like to use the remote to give the operator clearance from the side of the pier or away from the HPU. As the extractor is vibing, you will notice the pile start to settle. And once you've broken up freely within the soil, you can start to pull up. The hammer itself has about 80 tons of pull on the extractor, so you know what you're working with when it comes up. Once you vibe completely out of the soil, you turn the vibe off. And once it's out of the ground, you'll bring it alongside to where you can safely lay the pile down and it can be retrieved by other support equipment.